Have you ever wondered how integral computers have become in our lives? Today, these digital marvels hold sway over nearly every aspect of our existence. They're at the helm of businesses, driving innovation and efficiency. They're in our schools, revolutionizing education and making learning more accessible. In healthcare, computers are helping save lives, and in our homes, they've become our personal assistants, entertainers, and gateways to the world. Indeed, computers have reshaped our world, but have you ever wondered how these incredible machines are made? The creation of a computer starts with a plan, a blueprint, if you will. This is where engineers and designers come together, combining their expertise to craft the ideal machine. They meticulously plan out every detail, from the processing power, which determines the speed and efficiency of the computer, to the storage capacity that will hold all your precious data. But it's not just about the internal workings. The physical design of the computer is equally important. Is it going to be a compact laptop for on-the-go use, or a powerful desktop for high-end computing tasks? These are the questions that guide the design process. Each element is carefully considered and balanced against the others to ensure the computer as a whole meets the desired performance levels. It's a game of checks and balances, of trade-offs and compromises. Once the design and specifications are finalized, it's time to bring this plan to life. At the heart of every computer lies its most vital organ, the processor. This tiny piece of technology is responsible for executing all the commands you give your computer, whether it's opening a web page, running a program, or even just moving your mouse. But how does this microscopic marvel come to life? The journey of a processor begins with a simple yet precious material, silicon. This element is the second most abundant on Earth and is the foundation for every processor. The silicon is purified and heated until it forms into a cylindrical shape known as an ingot. This ingot is then sliced into thin discs, or wafers, which will serve as the canvas for our processor. Next comes the process of photolithography. This is where the magic really happens. Using a blueprint of the processor's design, light is used to etch the pattern onto the wafer. It's like using a stencil to draw a picture, but on an incredibly small scale. We're talking about etching billions of transistors onto a wafer that's no bigger than your fingernail. These transistors are the building blocks of the processor, and each one acts as a switch, controlling the flow of electricity through the processor. After the etching is complete, the wafer is layered with metal to connect the transistors and create a path for the electricity to follow. The wafer is then cut into individual processors, each one ready to be the beating heart of a computer. But it's not just about making the processor, it's also about making it better. With each new generation, processors become more powerful and efficient, shrinking in size while increasing in capacity. It's a technological race that's been going on for decades and shows no sign of slowing down. With the processor ready, we can now move on to the other elements that make up a computer. Just like a human brain, a computer needs memory to function. You see, the memory in your computer is like the short-term and long-term memory in your brain. It's where information is stored and retrieved when needed. Now, there are two types of memory in a computer: RAM, or random access memory, and storage, which includes hard drives and solid-state drives. Let's start with RAM. RAM is the short-term memory of your computer. It's a type of storage that allows data to be read or written in almost the same amount of time, irrespective of where the data is physically located. This is where your computer keeps the data it needs to access quickly and frequently. When you're working on a document, playing a game, or browsing the internet, the data for those tasks is stored in RAM. But here's the catch. Once the computer is turned off, or even just restarted, everything in RAM is lost. So, while RAM is fast and easily accessible, it's not a place for long-term storage. Manufacturing RAM is a complex process that involves a lot of precision. Silicon wafers are used to create tiny memory chips, which are then assembled onto a circuit board. These boards, or RAM modules, are what you see when you upgrade the RAM in your computer. And then there's storage. This is the long-term memory of your computer. It's where all your files, programs, and the operating system are stored. Unlike RAM, the information in storage isn't lost when the computer is turned off. It stays there until you decide to delete it or move it somewhere else. Storage comes in two main types: hard drives and solid-state drives. Hard drives use magnetic storage to write and read data, while solid-state drives, or SSDs, use flash memory. SSDs are faster and more reliable than hard drives, but they're also a bit more expensive. So in a nutshell, RAM and storage are the memory system of your computer. They work together to store and retrieve data, helping your computer function smoothly and efficiently. With the brain and heart ready, we're getting closer to a complete computer. Now that we have the essential components, it's time to assemble the body. This is where the magic happens, where the individual parts come together to form a functional unit. First, we secure the motherboard into the computer case. It's the backbone that holds everything together. We attach it carefully, ensuring that no static electricity interferes with the sensitive electronics. Next, we install the processor, the heart of the computer. It's placed delicately into the socket on the motherboard, then locked into place. This is the powerhouse, the component that performs all the calculations. Once the processor is secure, we place the RAM sticks into their respective slots on the motherboard. Think of RAM as the computer's short-term memory. It holds on to the data the processor needs right now, making sure everything runs smoothly. Next comes the storage. This could be a hard disk drive or a solid-state drive, depending on the computer's design. This is the computer's long-term memory, where all your files and applications are stored. It's connected to the motherboard using a data cable. Now that everything is installed, it's time to connect the power supply. This is the lifeblood of the computer, providing energy to all the components. Once everything is in place, we close the computer case, securing it with screws. But our work here isn't done just yet. We need to test the computer to make sure everything works as it should. This is called quality control, and it's a crucial part of the assembly process. We run diagnostic software to check each component, ensuring they're all functioning properly. This process might seem complex, but it's a testament to the intricate design and engineering that goes into creating these powerful machines. It's a delicate dance of technology where each part plays a vital role. Once everything is assembled and tested, we're left with the powerful machines we use every day. From designing skyscrapers to streaming your favorite shows, these computers are the result of careful assembly and rigorous testing. Now that we know how a computer is made, let's talk about how to use one. Understanding the basics of computer usage is like learning to walk before you run. It's all about getting comfortable with the device and learning to navigate through its many functionalities. Firstly, let's discuss operating systems. This is the software that manages all of the hardware and software on your computer. You interact with it through the user interface, which includes the desktop, start menu, and taskbar. Familiarize yourself with these elements and learn how to open, close, and manage windows. Next up, we delve into the World Wide Web. Browsing the internet is a key skill in the digital age. Start by learning how to use a web browser. Understand the difference between a search engine and a website, and get comfortable with navigating web pages, clicking on links, and using search bars. Lastly, we have software applications. These are programs that perform specific tasks. They range from word processors and spreadsheets to photo editing tools and video players. Knowing how to open an application, create, save, and organize files is essential. Remember, practice makes perfect. Don't be afraid to explore and try out new things. The more you use your computer, the more intuitive it becomes. Mastering these basics will set you on the path to becoming a proficient computer user. And so, that's the journey from a blueprint to a functioning computer. We've traversed the planning, creation, and assembly stages right through to understanding the essential use of computers. Next time you use a computer, remember the incredible journey it took to get to your desk.